Good morning. This is Nature of Matter 103, and what we're talking about today are the concepts of formal charge, resonance, and delocalization. And the homework for this is just to take the notes. So pretty simple. I'll assign you some practice problems out of the book this week. So we're going to start off with formal charge, and this will be part 1 of 103. So the concept of formal charge is just summarized with this definition here. It's a bookkeeping method to analyze the number of electrons an atom has assigned to it in a particular Lewis structure. So when you want to calculate formal charge, so formal charge equals the number of electrons an element brings into the molecule. So those are the valence electrons. Like oxygen would be 6 and carbon is 4, that kind of thing. And then you subtract the number of electrons assigned to the atom or the element in the molecule, where a bond equals 1 electron and a non-bonding pair is 2. Okay, so for instance, if we were looking at, as an example, we were looking at the sulfate ion, and we wanted to look at the formal charge on each atom in the sulfate ion. We would draw the Lewis structure first, and we would find that this guy has 6 plus 24 plus 2, 32 electrons. So we would draw sulfate like this, and that would take up 8 of our available electrons, and we'd have 24 left over. So we'd give an octet to each one of these oxygens. Put square brackets and a -2, we're good to go. Okay, so what we would do is calculate the formal charge on each of the atoms in the molecule. So for instance, if we were going to do the formal charge on sulfur, we would do sulfur, and we know that sulfur brings in 6, and in this molecule it has 1, 2, 3, 4 assigned to it, so that's a formal charge of 2. Each of these oxygens, the single bonded oxygens, we know oxygen also brings in 6, and in this molecule each of these oxygens has 7, so 2, 4, 6, 7 electrons assigned to it, so it has a formal charge of -1. So what we would do is go around and label each of these. This is -2, that's -1, that's -1, that's -1, that's -1. Okay, so that's just a kind of a bookkeeping thing. And I'll tell you what that tells us here in just a minute. There's a couple of little key tricks that you want to remember. And that is the sum of all formal charges in a molecule add up to the charge on the molecule. So you can see in my example here, we had, oops, this is +2, sorry. In my example here, we had sulfur, which is +2, and then we had 4 oxygens at -1 each, which would give us an overall -2. And there's our charge right there of -2. Okay, so if the molecule is neutral, then the formal charges add to 0. So that's something you want to remember. They're going to add it to the charge on the molecule. Okay, so what does formal charge, this is a kind of a separate idea, tell us? So that's great. We have this bookkeeping method to kind of keep track of who's got which electrons in the molecule. But what does it tell us? And that is, answer to that is which Lewis structure is most likely? Okay, and we want to remember with these Lewis structures that the Lewis structure that minimizes formal charge on all atoms, so that means closest to 0, minimizing. So we'll write that down, closest to 0. So that minimizes formal charge on all atoms and awards any negative formal charge to the most electronegative element is the most likely. Okay, so I'm going to keep this part in view and go to another page. I usually don't do this, but we're going to keep that visible and then bring paper down. Sorry, hang on just a second. Okay, so if we look at an example, we can go back to our sulfate ion. Oops, SO4 -2. So we know this is a possible Lewis structure for the sulfate where everybody gets an octet, everybody's happy. This is what we would have learned in first year chemistry, that this is the Lewis structure for sulfate. We can also have, because we know sulfur can hold more than 8 electrons as a central atom, we can have where one of the oxygens is double bonded to the sulfur. Okay, or we can show where there's 2 oxygens double bonded to the sulfur. Remember that sulfur can hold more than 8 valence or more than 8 electrons as a central atom. And and then we could also show, you know, another one with the sulfur having 3 double bonds, etc. And what we have to do is go through and analyze which one of these is most likely. And we want to go back to our statement earlier that the one that minimizes formal charge on all of the atoms and awards any negative formal charge to the most electronegative element is most likely. Okay, so we're just going to run through and calculate formal charge for each of the little atoms in the molecules. Sorry, my phone is weird here. Okay, so this sulfur, I'm just going to run through these. This sulfur would be +2, and each of those guys is -1. In this case, this sulfur is going to be 6 - 5, which is +1. And this double bonded oxygen is going to be 0. And then each of these guys is going to be -1. And this guy's are -1. Oops, these are 0. And then this sulfur goes to 0 in this structure because it brings 6 with it and then has 6 assigned to it. In this structure, we've got 0, 0, 0, which is good, and -1. And then the sulfur has a formal charge here that's negative because it's got 7 valence electrons attached to it, or 7 electrons attached to it in the molecule, and it brings only 6. So the most likely structure is the one that minimizes formal charge and awards any negative formal charge to the most electronegative element. So this is the most likely, because it not only minimized formal charge on several atoms, it got 0, 0, 0, but it also awarded negative formal charge to the more electronegative element, which is oxygen. Okay, so that's it for part 1. Thank you.